Okay, 5.6 is solve problems involving quadratic relations. Okay, so that's going to be our focus right now, solving problems. So I'm going to recap what an axis of symmetry is. So it's the vertical line through the vertex of a parabola. So I'm just going to give you a visual example right here. If we have the x-intercept of 2 and we have the x-intercept of 4, well, we know that parabolas are symmetric. And they're actually symmetric down the axis of symmetry. So this axis of symmetry is going to be x equals 3. It's going to be right in the middle of 2 and 4. The way we can find that is 2 plus 4, put axis of symmetry, and then we can divide that by 2, because it's just the average between the 2 points. Okay, and that's going to be our h value. And if we have our h value, what we can do to find k is plug in our h value into the original equation. So let's go ahead and try one of these hands-on. Okay, example 1. Use the zeros to find the maximum. Okay, so what that means is that we have to factor these equations first, find the zeros, and then we're going to use the zeros to find that middle point. Okay? So, does this equation have a max or a min? So the a value is positive, so it opens up. It's going to have a minimum. Minimum. Because the a value is positive. Now, find the zeros. Let's go ahead and factor this equation. Okay, we can pull out a 4 out of each one of these numbers. So, 4 is going to be our common factor, and we're left with x squared, okay, minus 18x plus 65. Okay, now on the side of my paper, what two numbers multiply to 65? 1 and 65. We have 5 and 13. Yeah, that works already. So -5, -13 will add to -18. So our equation is x minus 5, x minus 13, all multiplied by 4. Okay, let's find our x-intercepts. X minus 5 equals 0. Bring that -5 over. X equals 5. Now x minus 13 equals 0. Bring that -13 over. X equals 13. So, determine the x-coordinate of the vertex. We have the two zeros. It's going to look something like this, 5 and 13. In order to find that middle number so that we can find the axis of symmetry, all we're going to do is we're going to add those two numbers and average them out. So 18 divided by 2, our axis of symmetry is going to be at 9. So our vertex is going to lay on that 9. And to finish finding the vertex, what we do is we sub 9 into the original equation. Y equals 4, 9 squared. Let me do that. 4 times 9 times 9. And then minus 72 times 9 plus 260. So we have 324 minus, and then we have 72 times 9, 648 plus 260. And that is going to equal 260 plus 324. And I get -64, which in this case, it makes sense because our parabola opens up, therefore we have a minimum. So this number right over here is going to be -64. So the last part here, and it doesn't show, let me see. I'm going to go to the next page. Write the relation in vertex form. So let's just recall that our vertex was 9, negative 64. And our equation was y equals 4x squared minus 72x plus 260. So when we're looking to write our equation in vertex form, we know that this right here is the a value. It's the leading coefficient. And then we have h comma k. So when we look at the equation of a quadratic in vertex form, what we want to do is we want to sub in the a value, which we know is 4. Then x minus, we sub in the h value, which we know is 9. And then the k value, negative 64. I just want to point this out though. There is a negative sign right here built into the equation. So even if we have like a positive h value, it looks negative in the equation, and that's how it should be. Okay? And if we had a negative h value, it's going to look, positive in the equation. All right, so in example 2, use the zeros to find the maximum. So again, same thing. When we see maximum or the word minimum, we're thinking the vertex. Okay, so first of all, does this have a max or min? Well, that leading coefficient's 1, so a equals positive 1. So it's going to open up and it's going to have a minimum. Okay, find the zeros. So let's go ahead and factor. Okay, what two numbers multiply to negative 28 and add to 3? 128, 214, 3, 4, 5, 6, 7. 7 and 4 are going to work. And if they have to add to positive 3, then we're going to put that negative on the 4. Okay, so x plus 7 and then x minus 4. And we're going to take these two factors and we're going to equate them. Oops, x plus 7 equals 0. And we're going to have x minus 4 equals 0. We're going to equate them both to 0. And I'm just going to carry this over here. X is going to equal negative 7. And then the other x is going to equal positive 4. Okay, so just a visual, we're going to have positive 4 and we're going to have positive 7. And we're also going to open up. Let's do that one more time. Okay, so we need the equation of axis, which is just going to be the average between one second. This is negative 7. One sec. Sorry about that. We wrote it correctly as the negative 7, but then I drew it incorrectly. So negative 7 and 4, and again, yes, it opens up, so that's going to be fine. We have to find this equation of axis. So we're going to average negative 7 plus 4 and divide it by 2. Okay, and negative 7 plus 4 is going to be negative 3 over 2. If you want that as a fraction, just so it's a little bit easier, negative 1.5. Okay, and in order to find the vertex, we're going to take that negative 1.5 and we're going to sub it into the original equation. So plus 3, negative 1.5, minus 28. Okay, negative 1.5 squared. I get 2.25 minus 3 times 1.5, 4.5, minus 28. And when we solve for this, we get minus 28 plus 2.25, negative 30.25. So our vertex is going to be negative 1.5, comma, and then we can have here, it's going to be here. We're going to have negative 30.25. Now, as a reminder, we want to, for part E, sub these values right here into the vertex form of the quadratic relation. So we're going to get y equals 1, x plus 1.5 squared minus 30.25. Okay, so just to line these up, this negative 30.25 is the k value. This negative 1.5 subs into this negative h, and because of the double negative, it now becomes positive, and our a value is 1. We can actually leave that 1 out of the equation, and it's still equivalent.